Okay, so we're going to talk about exponential relationships today. And yesterday we did introduce the exponential equation, and we said that the general form of the exponential equation is y equals a bracket b to the power of x, and then close bracket, right? We said that A represents the initial amount or initial value. B represents your base, which is what? Exponential ratio. That's right. So it's either a growth ratio or a decay ratio. We call that factor, the exponential factor, the decay or the growth factor. Okay? So B represents the growth or decay, so either or factor. Okay? And then I'm going to add to it as well. Remember I said, technically speaking, at the beginning, we don't introduce that A, but I just don't want to give you an equation and then like 2 lessons later, give you another equation. So I'd rather if I introduce the full equation to you with the A value as your initial value. Okay? Remember that A is your initial value. Sometimes A is 1. Right? So if you see an equation that looks like this only, right? That means your A value is 1, because technically speaking, this is your B power x, and then you don't have a value here, which means it's 1. But sometimes when you see something that looks like this, right? You know that. What's your initial value here? 100. What's your growth factor? 2, right? And then your exponent is x. So this way, I just want you to see that sometimes you don't see that initial value, but that means it's 1. All right? So let's look at the two different exponential relationships. So we have two different ones. The first one that we're going to see is called an exponential growth, and the other one is called an exponential decay. Okay? An exponential growth, that means it's increasing fast, right? First, it's going to increase slowly, and then it's going to increase fast. This is what we saw yesterday in our example, correct? When we were folding the layers. And then we're going to see an exponential decay, so we see a very fast decrease, and then a slow decrease, and then it flattens out. So what's the difference between I'm looking at this equation right here, and I'm looking at this equation right here. What do you notice the difference between the two equations? One is a 2 base, and the other one is a 0.5. Why is a 0.5 an exponential decay?
Because you're multiplying the y values by
It's 0.5 multiplied by itself, so multiple times, right? But why 0.5 gives you an exponential decay? That value is between what and what? 0.5 is a value between 0 and 1, right? So we'll talk about that in a bit, but if you look at the base here, this base is actually between 0 and 1. This base here is greater than 1, okay? So if your base is between 0 and 1, so if your base is a 0 decimal something, right? We know right away that this is an exponential decay. If your base is greater than 1, then we know it's an exponential growth. Okay, so these are your two differences here. So when b is greater than 1, the relation is exponential growth. And when b is between 0 and 1, the relation is exponential decay. So if you look at your graphs, it's growth because you see that it's growing slowly at the beginning, and then you're going to see a very fast increase after, right? While the other one, you see it's decreasing fast at the beginning, and then you're going to have a slow decrease after. All right? So remember that I said B is either called the growth or it's called the decay factor, right? So in the case of an exponential growth, we call it growth factor. Okay? In the case of exponential decay, we call it decay factor. Okay? So, the question here, you have a question that asks you to find the x-intercept. Okay? To find the x-intercept, that means I have to set y equals to 0. Anytime you're finding an x-intercept, you set y equal to 0. So I have this, y equals 2 to the power of x, yes? And I'm going to set y equal to 0. And I have to solve for x. Okay? There's no way, well, there is, excuse me. There is a way, but we don't learn that way here, okay, to solve for x. So the only way that we're going to learn here is guess and check. Yes?
So
anytime you find the x-intercept, you set y equal to 0. Okay? Because remember that your x-intercept is going to be somewhere on the x-axis, right? And anywhere on the x-axis, y is equal to 0. Any point right here, the y value is equal to 0. Whatever that point is, the y value is equal to 0. Okay, give me a value for x. That might, if I do 2 to the power of that value, is going to give me 0. 2 to the power of 0? What's 2 to the power of 0? 1. So it's not equal to 0, no? All right. Give me another value for x. We can try. I can't bring 2 over because it's 2 to the power. So I'm going to have to do guess and check. Plug in values for x. Give me value for x. 1? What's 2 to the power of 1? 2. So it's not equal to 0. Okay, plug in a negative number. What would you want to plug in? 2 to the power of what? Negative 10? Okay. Can you do on the calculator what's 2 to the power of negative 10? 1 over 1024. So is that equal to 0? No, it's 0.000 something, right? But it's not equal to 0. Okay, give me another value. 2 to the power of negative 2? What is that? 0. What? 25. So it's not 0, right? How about 2 to the power of negative 100? Times 10 to the power of what? Negative what? Negative 31, right? So it's still not a 0. It's 0.00000. Keep counting so many zeros. 7. Okay? So it's never going to be 0. Remember we talked about this yesterday. We said that no matter how many pieces I rip this into, it's still going to have a molecule in there. Right? I'm going to still be able to use a microscope and look at it. Okay? So that means I will never have, unless we have transformation. So I shouldn't say we'll never have, but in this course we will never have. Okay? Unless we have a transformation, right? Remember how we did the quadratic transformation? There is also exponential transformation, but we don't do that here. Okay? Unless we have the transformation, there's no x-intercept. Okay? Because even if I plug in 2 to the power of negative 100, it is still like 0.0000000, so many zeros, right? 7, right? It's never going to be 0. Does that make sense to you guys? So you see that your graph, if you look right here, your graph is approaching that x-axis, but technically speaking, if you zoom into it, it is never going to touch it. This will never ever touch unless you're doing transformation, which is we do that in grade 2 advanced function. Okay? How about the y-intercept? When I find the y-intercept, what do I set equal to 0? X equals to 0. Okay, so if I do the y-intercept, y equals 2 to the power of 0. What's 2 to the power of 0? 1. So my y-intercept is 1. How about for the second equation? Can I find it for the second equation? 0.5 to the power of 0 is 1. Okay? It is going to be always 1 if I don't have an initial value. Okay? What's my initial value here? What's my initial value? 1. 1. And that's why it's 1. What if your initial value was 100? So let's say if I have this question. What would be your y-intercept? 100, right? Because I will have 100, 2 to the power of 1, which is 2 to the power of 0, sorry. 2 to the power of 0 is 1. So that's 100 times 1, which is 100. And remember, what does the word initial value mean? When what is equal to 0? When x is equal to 0. That's what the word initial value means. Initial means when x is equal to 0. Okay? So this is a side example. Okay? So if my initial value is 1, right? My y-intercept is going to be 1. So I'm going to give you some examples here, and then you're going to tell me a couple things. You're going to say exponential growth or exponential decay. Okay? You're going to tell me what your initial value is and what your growth or decay factor is. Okay, so I'll ask you the questions. So if I have y equals 1.03 to the power of x. Exponential growth or exponential decay? Growth or decay? Growth. Why growth? The base, which is 1.03, right? It's more than 1, right? Yes, it's just 0.03 more than 1, but it's more than 1. That's going to be an exponential growth, okay? Now, how about your initial value? What's your initial value here? 2. So that's my initial value. And what is your growth factor? 1.03. Okay? Are we good? All right, let's look at another example. Thank you. Decay? Okay, why? It's between 0 and 1, right? 1/3 is between 0 and 1, so that's a decay. Okay, that's 0.3333, right? Okay, what's your initial? And what's your, is it a decay factor or a growth factor? Decay factor, which is? So 1/3, right? Good. Okay? So you're looking at it, you know if it's going to be an exponential growth or exponential decay, you know what's your decay or growth factor, and you know what's your initial value. So these are side examples, okay? Are we good with this? All right. Use the table of values to answer the questions below. So I have my x values, and I have my y values, and it's asking me to find my first ratio. So to find my first ratios, what do I have to do? y2 divided by y1. Okay? So that means I have to go this divided by this. Yes? What's 3 divided by 1? 3. Yes? Because that's a formula. The formula is y2. All right, so then I have y2 divided by y1, so that's 9 divided by 3. 27 divided by 9. And then 81 divided by 27. That's 3. Okay? So, is my first ratio constant? Yes, it is. Okay? Since my first ratio is constant, then I know it's an, what kind of function? Exponential function, right? So, is the relationship exponential? Give a reason for your answer. Yes, the relationship is exponential. And I know that because the first ratio is constant. Are we good with that? Okay. If my first ratio is not constant, then it's not an exponential equation. The first ratio. The first ratio. Now, the question is asking me for the equation of the relationship. Okay? So, since it's exponential, what would be my general equation? Y equal A, B. Good. Now I have to replace A and replace B. What do I replace B with? 3. Because remember that your ratio that you get here is your base. Okay? So, good. So I replace B with 3 to the power of x, yes? Now what would I replace A with? What does A represent? What does A represent? Initial. That means when x is equal to 0. So I go to my table of values. I look for the x equal to 0, right? My y value is 1. So therefore, my initial value is 1. So I'm going to replace it with 1. Technically speaking, I don't have to write that 1 because it's the same thing if I write it as y equals 3 to the power of x. That's the same thing. But what if my initial value was 20? Then you have to include it right here. Okay? So if you get a table of value, right, where you have x and y, and then 0, 20, let's say 140, 280, right? That's another example I'm giving you here. 3, 160. Let's say we have this example, right? I do my first ratio to find my base, so that's 2, 2, 2. My equation is going to be y equals 2. My initial value is 20 because that's the one that belongs to the 0. My base is 2 because my ratio is 2 to the power of x. Okay? So this is another example where it gives you an initial value that's not equal to 1. Does it make sense to you guys? There will be a question on your assignment that's similar to this. So you need to be able to figure out what your initial value is and put it into your equation. Okay?
So what if the x did have like 5 there and y is 20?
X is 5?
Yeah.
Then you won't be able to find your initial value in this case. Right? They have to give you that 0, or you have to solve for it. Okay, so a way to solve for it, which I don't need you to do that in this course, but there is a way to solve for it. So if I know, let's say the point is 140, right? I don't know what A is, so I'll put, I have this, right? I put 40 for Y, and then 1 for X. So that's going to be 40 equals to A times 2, divide by 2. So that's 20. Right? So it's like we did it with a quadratic where we plug in a value to solve for A. Same thing, but we don't do that with exponential. Okay? Usually I do give you your initial value. Okay? You can solve it this way if this point was not given to you. Okay? Okay, so they want me to graph the function, okay? So I'm going to graph the function, and I'm going to go up probably by 10. So 0, 1, 1, 3, 2, 9. 0, 1, so it's going to be almost here. 1, 3, 2, 9. What was the 3? 3 is 27. And what was 4? 81. Yes? So you see I put arrows because I know it's going to be continuous. It's not going to stop right there. And what should I put on my x and y axis? Do I have any values for x and y? No, it doesn't say, so I just put x and y. I put x here and I put y here because they did not give me any labels for my x and y. If they gave me labels for x and y, so let's say x is the number of folds, y is the number of layers, then I have to include the title on my graph. Okay? I'll get back to this in a second.